Hello everyone, how are you all? Here we will continue the geometry lessons. Today we will concentrate on lines and angles. In this topic we will be discussing these topics: complementary angles, supplementary angles, adjacent angles, linear pair, vertically opposite angles, pair of lines. There are different pair of lines: intersecting lines, parallel lines and perpendicular lines. First, we talk about the complementary angles. When the measure of two angles is 90 degrees, then the angles are called complementary angles. So, here we have few questions. We will check whether the given pair is complementary or not. In the first question, we have two angles, one is 70 degrees and another is 20 degrees. Let us see the total of the two angles. 70 degrees plus 20 degrees gives you the total measure of 90 degrees, which is right angle, and they are complementary angles. Similarly, if you check the second question, it is 75 degrees plus 25 degrees. It gives you the measure of 100 degrees, which is not equal to 90 degrees. So, 75 and 25 degrees are not complementary angles. Similarly, we can check this question: 48 degrees plus 52 degrees is equal to 100 is not equal to 90, so not complementary. Same way, we can check the given pair is complementary or not. 35 plus 55 is not equal to 90, it is equal to 90 degrees, so they are complementary angles. Now, let us see the meaning of supplementary angles. The supplementary angles are the angles where the sum of the two angles must be equal to 180 degrees. That means the measure of any two angles is 180 degrees, then the both are called supplementary angles, and one angle is supplementary to another. These two pairs are said to be supplementary angles. Let us see few questions here. Can two obtuse angles be supplementary? Yeah, as we know the meaning of obtuse angle, it will be always greater than 90 degrees. Then if you are adding the two angles which are more than 90 degrees, you will be getting the sum more than 180 degrees, but we must get the angle of 180 degrees. Sum must be 180 degrees, but we are not getting, we are getting more than that. So, this cannot be possible. The obtuse angles cannot be supplementary. So, the answer will be no for this question. Similarly, if you see the second question, can two acute angles be supplementary? Let us check the meaning of acute angles. Acute angle is an angle which is less than 90 degrees. When you add the two angles with less than 90 degrees measure, you will be getting always less than 180 degrees. That means you will not get 180 degrees. That means here also the two acute angles will not be supplementary angles. So, the answer will be no for this question. Same way, you can check the third question. Right angles be supplementary? Let us see what is the meaning of right angle. You must know that right angle is 90 degrees. So, let us take 90 degrees plus 90 degrees gives you 180 degrees. So, they are supplementary angles. So, here the third question answer will be supplementary angles. Let us see what is the meaning of adjacent angles. Adjacent angles. For the two angles to be adjacent, we need to see the conditions. The conditions are here. The common vertex should be there. There should be a common vertex for both the angles, and common arm must be there. For example, if you consider here, this is a common arm here, okay. And at the same time, the third condition is the non-common arms are either side of the common arm. These are the conditions for adjacent angles. For example, if you see the first example here, angle 1 and angle 2, here these two angles are adjacent angles, as these two angles, angle 1 and angle 2, are satisfying the three conditions. Let us see, the common vertex is here and common arm, here you can assume this is the common arm. At the same time, the non-common arms, this arm and these arms are non-common to these two angles. So, they are either side of the common arm. So, this particular angle 1 and angle 2 are adjacent angles. Let us check the same conditions for this. Here angle 1 and angle 2, they are having the common vertex for the both angles, and there is a common arm for this angle, these two, and this one non-common arm, and this is another non-common arm, and these are both are either side of the common arm. So, these are also adjacent angles. This one also adjacent angles. Let us consider this example. Here we do not have common arm. Here angle 1, here vertex is here, and the angle 2 vertex is here. There is no common vertex. So, there is no common vertex. This particular line, this particular angles failed the first condition itself. So, these are not the adjacent angles. Let us see few questions on this adjacent angles. Can two adjacent angles be supplementary? Yes. The two adjacent angles can be supplementary. Supplementary is 180 degrees, and any two angles you can take, and the sum, for example, you can see here angle 1 and angle 2, you can see they are supplementary angles, 180 degrees, a straight angle here. So, the answer for the first question can be S. And can two adjacent angles be complementary? Yes, of course, they can be complementary here. That means any two angle, you can take one right angle, for example, you can convert one right angle into two different angles. At the same time, obtuse angles can be adjacent angles. The obtuse angles can also be adjacent angles. And can acute angle be adjacent to obtuse? Yes, any angle can be adjacent to any angle. You can see until 360 degrees total, you can have any type of angles here, the adjacent angles. Let us see the meaning of linear pair and vertically opposite angles. Linear pair, the any two adjacent angles whose total measure is 180 degrees is said to be the linear pair. So, the two adjacent angles whose total measure is supplementary or 180 degrees are called linear pair. For example, if you take angle 1 and angle 2 are the two angles on a straight line, you can see when you add up angle 1 and angle 2, the total measure is equal to 180 degrees. So, they are linear pair. Similarly, if you see the second example, here when you add up angle 1 and angle 2, the measure will not be equal to 180 degrees, it will be less than 180 degrees. So, these two angles are not linear pair, these are not linear pair. Now, let us see the vertically opposite angles. Whenever the two lines intersect at one point, then they form four angles. Here you can see the line L and the M are intersecting at some point, and now they are forming four angles. These four angles, if you see 1, 2, angle 2, angle 3 and angle 4. Angle 1 and angle 3 are called vertically opposite angles. Similarly, we have another set of vertically opposite angles, that are angle 2 and angle 4. And one condition is applicable here: whenever the two lines are intersecting, two pairs of vertically opposite angles will be formed, and the measure of the all vertically opposite angles are equal. For example, angle 1 is equal to angle 3 here. Similarly, we can have angle 2 and angle 4 are pair of vertically opposite angles here. And at the same time, we can say angle 2 is equal to angle 4. The same measure will be having. Let us see the last topic for today's class, that is pair of lines. There are different types of pair of lines, such as the intersecting lines, parallel lines and perpendicular lines. When the two lines are intersecting or they meet at one point, they are said to be intersecting lines, and the two lines, whenever they are produced, they are not meeting at any point, then these two lines are said to be parallel lines. At the same time, if the two lines are perpendicular to each other, I mean they are making right angles at the intersecting point, then they are said to be perpendicular lines. For example, let us take two lines, one line L and line M. These two lines are meeting at some point, say P. These two lines are now said to be the intersecting lines. At the same time, if you see the two lines which are not meeting, whatever the length you are producing them, they are called non-intersecting lines or parallel lines. And if the two lines are intersecting at right angles, then they are said to be perpendicular lines. You can see here they are the L and M, these two lines are vertically intersecting at some point, they are meeting at right angles, they are called perpendicular lines, and we can keep the particular notation for representing these lines. For example, L and M are intersecting lines. And L and M are parallel lines. The notation for the parallel lines is this. And perpendicular lines, L and M are perpendicular. The notation can be written as perpendicular sign. L is perpendicular to the line M. So here is the end of today's topic, students. So if you understood the topic, you can share, like and subscribe my YouTube channel. Thank you for watching.